In this video, we are going to learn how to name ionic compounds containing polyatomic ions. So in the previous videos, we have discussed what is an ionic compound, how to name different ionic compounds based on the metal ion, and how to write their formulas, but we have not yet discussed the naming of ionic compounds with polyatomic ions. Now, starting with what is a polyatomic ion? So it is an ion that contains a group of atoms bonded to each other or connected to each other, that the group itself has an overall electric charge, and this becomes very important. And bear in mind, these are not the same as a molecule because they contain a charge. A molecule would have a neutral charge, but a polyatomic ion will have an overall charge, even if the bonding looks similar to molecules. And it's very important for us to know that polyatomic formulas, names, and charges must be memorized. And for reference, I have included on this slide right here the list of polyatomic ions that you are required to memorize. And this is from the textbook, but you can again find it here in this video and on the set of slides with the video. A very special group of polyatomic ions are oxyanions. And from the name, the word oxy right here indicates that these anions contain oxygen. And of course, it is an anion, so it will be negatively charged. Okay, and polyatomic oxyanions, they contain one or more oxygen in addition to another elements. Oftentimes, these oxyanions will form a series, and it's sometimes tricky if you don't have rules to name these ions or oxyanions in the series. So to distinguish between them, we're going to go through a simple rule. So if you have an oxyanion with more oxygens, it usually ends with the suffix ate. If the oxyanion contains less oxygen in comparison to another oxyanion, it usually ends with the suffix ite. Now, I have an example right here to clarify. So for example, here we have NO3 minus and NO2 minus. So NO3 minus contains more oxygens than NO2 minus. So the more oxygens will end with ATE. Okay, so it becomes nitrate. And for the less number of oxygens, it'll be nitrite with the suffix ite. Same thing with this example right here. So this oxyanion contains sulfur. And for the more oxygens, it's going to be sulfate. For the less number of oxygens, it's going to be sulfide. Sometimes the oxyanions can, or these series of oxyanions can contain up to 4 or 5 in the series, 4 or 5 polyatomic ions in the series. And these have an additional set of rules. And I'm going to illustrate with this example in the table below. And for the highest number of oxygens in the series, we are going to split the name or write the name using 3 steps. So we're going to start with per, followed by the name. The name is usually indicates the other atom in addition to the oxygen that's present in there. And then ATE. So we agreed ATE indicates that this is more oxygens. And as an example, ClO4 minus, so per, because it has the highest number of oxygens in the series, chlor in the middle, which is the name right here, So this is the name and indicates that it has chlorine, and then the suffix ate at the end. For the second most oxyanion that has oxygens, we will disregard the per, so we'll just have the name and then the suffix ate. So looking here, we have chlor and then 8. So for ClO 3 minus. Now, the one that follows in the series, now, mind you, we are reducing the number of oxygens. So the lower number of oxygens, or the second least number of oxygens, will be the name followed by the suffix ite. So in this case, ClO2 minus becomes chlor for the name, and then ite. And then for the least number of oxygens, and in this series, we have here 1. So for one oxygen, think about it that it's deficient or lacking. So we add the prefix hypo at the beginning, followed by the name, and then finally ite at the end. An example again, ClO minus, or can be written as OCl minus. These two can be used interchangeably and becomes hypo, the prefix, chlor for the name, and then ite for the suffix. Now, in this series, I used chlorine oxyanion, okay, or an oxyanion containing chlorine, right? But the chlorine can be interchangeable with bromine or iodine. Okay, so you will apply the same exact rules to these oxyanions. Now, let's move on and check our understanding and try to name with me, or alternatively, write the formula for these two examples. So starting with the first one right here. So for the first example right here, we have NH4 to HPO4. So let's start with the first portion right here. So here, because this is a polyatomic ion, so this actually contains two types of polyatomic ions. So it contains a cation and an anion. So for the first part, we're going to start with the cation, and here it is ammonium, okay? And we have here we'll move on to the anion, which is the hydrogen phosphate. So it becomes ammonium hydrogen phosphate, okay? Now, for the second example, magnesium perchlorate. So we agreed here we have magnesium. So we'll follow the rules here for writing the formula of an ionic compound. So magnesium is Mg2+, and then perchlorate. So per indicates that it has the highest number of oxygens. Chlor means that it has chlorine, and A to show that it has 4 oxygens. So it becomes ClO4 minus. And then we will use the crisscross method to do this. So it becomes MgClO4 twice. And this means that for every magnesium 2+, you have 2 perchlorate ions. Now I want you again to pause your videos. Sorry, it's not videos, it's a video, and work on these examples with me. And I'm going to very quickly show you. So we have CaClO2. We need to write the names or the formulas. So CaClO2 means that we have here calcium is my cation, okay? And then ClO is only 1, so becomes hypochlorite. okay? Because hypo, it's lacking, it's the least. So hypo and then chlor for chlorine and then ITE for the least number of oxygens. Now B is KNO2. KNO2 is potassium, okay, with the cation, okay? And then NO2 is nit. So nitro is for nitrogen. And then because it has less number of oxygens compared to nitrate, becomes nitrite. C, calcium dihydrogen phosphate. So write the name as the, or write the formula as the name is written. So we have calcium, okay? And then we have dihydrogen phosphate. So H2PO4, okay, minus. And calcium, bear in mind, has a 2 plus charge. So we do the crisscross method. So becomes calcium twice, okay? Now the last example that we're working on, or practice problem, is aluminum. Aluminum is Al3 plus. And then we have phosphate, which is 3 minus. Doing the crisscross method, we have here Al3, BO4, 3. Do not forget to reduce to the least common denominator. So we have AlPO4.